I just like to take a step back and say, wow, we've come a long way in this amount of time. Almost a 1,000x increase. Now I will also say real quickly, you probably have noticed a name change at this point. We're calling this Wi-Fi 6. It's also 802.11ax, but more and more I think we're going to get away from referring to it as 802.11 something something, because that's complicated, and the Wi-Fi Alliance has decided, let's just go to numbers. So we got Wi-Fi 5 as our last generation, 4 before that, so on and so forth. There are some major improvements to get us to this 10 gig theoretical throughput. Now we know in real practice we're not going to get that much, but this is to address challenges that are coming in the future. Last year I sat at Cisco Live at practically this date, and they said the campus of the future is wireless first. So take that in for a second. Wireless first. I think any of us have certainly settled on the expectation that wherever I can plug in, I'm going to do that. That's going to be a much better, more stable connection. But if the campus of the future is truly wireless first, that brings a different set of expectations to wireless that we're going to have to manage. So who's ready to put a usable and reliable IP phone on wireless and feel good about doing it? Who's ready to connect 1,000 devices in a building to wireless and feel good about doing it? Or connecting some high bandwidth, latency sensitive application to wireless and feel good about it? If wireless is truly the first thing that we try and connect with on a campus, those things have to be true. We have this dramatic bigger and badder wireless stream that's being built. At the same time, we have a lot of little endpoints that need to reliably service these itty-bitty payloads that are going to come from all these different IoT devices, all constantly interrupting our airspace just to say, I'm here, I'm here, I'm here, I'm here, I'm here. And that is a problem for our current wireless technology, because every time somebody sends a transmission, it means it's a time that somebody else can't send a transmission. And there's only so many spots in that lane that we can send. So we need something different. I'll touch on this at the end just briefly, but 5G is certainly in view here as well. Cisco, in every published article I've seen from them, is advertising 5G and Wi-Fi 6 as complementary technologies. They work together. It's not a Wi-Fi is going to be overtaken by 5G or vice versa. They work together, and Cisco's really working to provide some seamless connectivity. If you want to dig into open roaming, that's an interesting partnership that they have with 5G service providers, so that devices can seamlessly move from cellular to Wi-Fi, back to cellular, back to Wi-Fi, without having to constantly re-authenticate and join this network and that network. Some pretty cool stuff as you think about the future and just being connected all the time as we move around. So this is actually borrowed from cellular technology. We've probably already all experienced this a little bit, whether you're at, not in a while because we social distance now, but if you're in a crowded space, at a mall, at an airport, some kind of sporting event, and maybe it's a sporting event, it's halftime, everybody jumps on the public Wi-Fi and it crawls. It absolutely crawls. The reason is we filled up all our time slots. So in that crowded space, I'm not just supporting, in this case, 8 clients. I'm supporting, maybe 50 clients or something like that. So I've got to wait my turn before I can send a transmission again. The way cellular technology works is more subdividing these channels. So what do you do in that instance? You pull up your phone, you turn off Wi-Fi, and you go to 4G, and all of a sudden your transmissions go through pretty well. So this is being introduced. It's not exactly the same as cellular, but it's a similar idea. And this is going to help with client density we can service more clients, we can service more bandwidth. So those two kind of scenarios I talked in the beginning, AR, VR, 4K, 8K streams, well, I can use all this extra bandwidth to push that data. If I have 1,000 IoT devices, I can use this extra bandwidth and segmentation of OFDMA to get a packet from each one of those clients transmitted and off and running without a bunch of contention. So this is a huge part of the advancement in Wi-Fi 6 that we're seeing. So of our 6 reasons, OFDMA kind of checks 2 of these boxes. It is involved in a couple of the other ones: higher capacity and improved interference mitigation, quality of experience, which certainly quality of service is something that tries to accomplish that quality of experience. But now we get to measure it a little bit more with some of the analytics and telemetry data that comes out of Cisco's products. But there's another component of Wi-Fi 6 that is going to help with this kind of scheduling. So target wake-up time is really neat, and I think will help on the IoT side especially. So I can, an AP can kind of instruct a client, or the client can request this from the AP that I don't really need to talk to you again for a while, all the way up to 5 years. That is a long time for somebody not to come back and talk to us. But we have that capability. And what this allows you to do is get incredible battery life, because that device can then power down and not be listening for beacons from the AP, not be sending, hello, I'm still here, updates. It's just an agreement between the AP and the client to say, hey, I'm not going to talk to you for a while. So, personally, I see this becoming extremely valuable in the IoT space. So that can dramatically extend battery life on IoT devices. And in kind of the average, they're showing 3 times better battery life. This will also work on a micro scale. So it's not just I won't talk to you but once today. I'm not going to talk to you for 105 milliseconds, which to you and me sounds like you can't possibly save that much power. But in the electronics world, that is a long time that I can power off my radios and not use juice from my batteries. So this gets into kind of handset devices, our cell phones, so on and so forth. And so this targeted wait time really introduces some good benefits for our devices. All right, so with this kind of deterministic scheduling, we can check off 2 more: reduced latency. And that just comes from, hey, I'm kind of busy right now, let's talk again in that 100 milliseconds or so. It also improves power efficiency, like we talked about.